Import the necessary libraries. Requests, JSON, SYS, pandas, and PyQt6 modules. Here, we have the main window class, which inherits from Qt Widgets. QMainWindow. This class represents the main window of our application. Inside the init method, we call the superclass initializer and then load the user interface with UIC load UI. This links our Python code to the UI file we created separately. Now let's look at the main execution block. When we run the script, it checks if the name is set to __main__, ensuring it's the main module being run. We instantiate a QApplication object. This is the backbone of any PyQt application and is necessary for any GUI app. Next, we load a QSS file, which is similar to CSS for web development. It's used to style our application, making it look sleek and professional. We then create an instance of our main window class and display it with the show method. Finally, we enter the main loop of the application with app_exec, which waits for user interaction. Let's check out the main parts of our PyQt app. We have two big sections, task thread and main window. Task thread does stuff in the background so your app doesn't freeze. It has init method to set it up and run to do the background work. Over in main window, this is where we see everything happening in the app. It's got a bunch of methods, like one for setting up, init method, one for connecting buttons, init signal slot method, and one for picking files, get file path method. We also get data from the user with get form data method, check it with check input data, and clean up with reset style sheet and clear form method at the end. Submit saves the data after making sure it's all good. The init signal slot method is where we'll connect buttons and other widgets to the functions that define their behavior. It's like telling the buttons what to do when they are clicked. Next, we have init nationality method, which will populate a combo box with different nationalities, complete with flag icons. This makes our form more interactive and user-friendly. With get file path method, users will be able to open a file dialog and select an Excel file. This is crucial for applications that process data. The get form data method is where the magic happens. Once the user fills out the form, this function will collect all the input data for processing. Data validation is key to preventing errors. Check input data method will ensure that the user inputs are correct and will give visual cues if there are any mistakes. If an error is found, reset style sheet method will be called to reset the input fields to their default styles, providing a visual indication that the user can try again. Users might want to start over. And clear form method gives them that fresh start by clearing all the fields in the form. Finally, when everything looks good, submit will take the data and save it to an Excel file. Define some class constants for stylesheet colors and an API endpoint. The reset_color and error_color will be used to provide visual feedback on the form, while the nationality_URL is set for fetching country data. Here we initialize the UI elements. Each line connects a Python attribute to a widget in our UI. This includes text fields for the file path, user's first and last name, age, gender, nationality, email, and phone number. We also have buttons like select folder BTN and entry data BTN, which users will interact with to select files and submit data. The init nationality method call will populate a combo box with flags representing different nationalities. It's a dynamic way to make the UI more engaging. Lastly, init signal slot method is where we'll connect the UI elements to their respective functions, enabling our app to respond to user events. We connect the select_folder_btn's clicked signal to the get file path method. When the user clicks the Select Folder button, a dialog for choosing a file will appear. Similarly, when the entry data BTN is clicked, it will trigger the submit method. This is how we gather and process the data entered by the user. But what about when a user makes a mistake or changes their input? That's where these text change connections come into play. Any modification in the target file path, first name, nationality, or email fields will call reset style sheet method. This resets the field style, removing error indications after a correction is made. This method begins by preparing an empty list to hold flag URLs destined for asynchronous loading. We know users hate to wait, so we'll make sure our application remains responsive while it fetches the data. It's always good practice to clear existing items before populating a combo box, ensuring we're starting with a clean slate. Next, we make a request to the REST countries API. This service graciously provides us with a list of countries and their flags, all neatly wrapped in JSON format. After fetching the data, we check if it's valid JSON. This is a crucial step as it prevents our application from crashing due to unexpected data formats. With valid data in hand, we iterate through each country, extracting the common name and the SVG URL for the flag. Each name is added to the combo box, and the flag URL is stored for later retrieval. Since fetching images can be time-consuming, we offload this task to a separate thread. This way, our application's interface remains snappy while the flags are being loaded in the background. Finally, we ensure our main window is visible, signifying the end of the initialization and the readiness of the application for user interaction. The TaskThread class. Let's unpack how this class handles loading nationality flags without freezing our GUI. In the constructor, we're passing in two crucial pieces of data: the target combo box object and the list of flag URLs. These are stored as attributes for use within the thread. The run method is where the action happens. This method is automatically called when the thread starts and is the heart of our asynchronous operation. Here, we loop through each flag URL. For every flag, we make an HTTP request to fetch the image data. This process is network I/O bound, and if we ran it on the main thread, our users would experience a sluggish interface. Once we have the image data, we convert it into a QPixmap, which is Pyke's way of handling image data. From there, we create a QIcon, a widget that can be displayed in our combo box next to each country's name. Finally, we use setItemIcon to set the icon for the corresponding index in the combo box. And because we're in a thread, all of this happens without interrupting the user's experience. The getFilePath method is triggered when the user wants to select an Excel file. It's designed to open a file dialog window, which is a standard open dialog you've likely encountered in many applications. Here we call QFileDialog getOpenFileName. This function creates the dialog window. We provide it with a window title, in this case, Open Folder, though Select File might be more accurate. We also specify a filter to only show Excel files with the extension XLSX. Once the dialog window closes, we check if a file was selected. If the user didn't cancel the operation, we'll have a path to the chosen file. Before we update our text field, we clear any existing text to avoid confusion. Then we set the text to the newly selected file path, making it visible and accessible to the user. The getFormData method starts by gathering all the inputs from the user. It's meticulous work, ensuring every piece of information is accounted for. We see here that each input field, from the file path to the phone number, is carefully read. Notice the strip method. It's used to clean up the text, removing any leading or trailing spaces that might have been entered accidentally. Once collected, the data is organized into a dictionary. This format is a programmer's best friend for managing related pieces of information. It makes the data easy to access and manipulate later on. Before we can use this data, we must ensure it's correct. A separate dictionary is created, mapping the form fields to their corresponding values. This will be used for validation. The data is then passed to the checkInputData method, which performs the validation. It's like a bouncer at the door of a club, only letting in the good data. If the data doesn't pass the validation, the method returns none, stopping the process right there. But if everything checks out, it returns the file path along with the clean data, ready for the next steps in our application's workflow. This checkInputData method serves as our gatekeeper, ensuring that the data entered into our form meets our standards before proceeding. We start by setting a flag, check_flag, to false. Think of this as a green light that will only turn red if we encounter any errors in the data. Notice how we handle the email validation. We first extract the email data with PyQt for a specialized check, keeping it separate from the other inputs. Then we iterate through the remaining data. For each field, we check if it's empty. If we find an empty field, we turn our green light to red and apply an error_color style to that particular widget. This visual cue immediately informs the user that something needs their attention. Next, we come to the email. If the email is missing or doesn't contain the it symbol, it's flagged. The corresponding widget is also styled with the error_color, signaling an issue. By the end of the method, if any errors were found, check_flag remains red, and the method returns true, indicating that validation failed. If all is well, the green light stays on and we return false, signaling that the data is good to go. Let's look at reset stylesheet method. When a user corrects their input after making an error, we want to provide immediate feedback that the error has been resolved. This method gets the object that emitted the signal, typically a text field, and resets its stylesheet to the default color, wiping away the error indication. We use the sender function to identify which widget sent the signal. It's a smart way of making our method adaptable to multiple widgets. Moving on to clear form method. This method is straightforward but essential. It clears all text fields in our form. This can be used to reset the form after submission or when the user wants to start over. Each text field's clear function is called, ensuring that when we say clear, we mean it. No traces are left, giving a clean slate to the user. Let's dive into a key feature of our PyQt application, the submit method. This function is crucial for taking user input from the form and saving it into an Excel file. We begin with a try block, which is a good practice to catch any unexpected errors that might occur during the submission process. First off, the method calls getFormData method to retrieve the information entered by the user. This data must be valid for the submission to proceed. If valid data is returned, it's unpacked into file path and user data. This step separates the path to the Excel file from the actual data the user intends to save. Using the power of pandas, a popular data manipulation library in Python, we read the existing data from the Excel file into a data frame. Then we create a new data frame for the user's data, ready to be inserted. The method offers two ways to insert data. The first appends the new data to the end of the Excel file. The second allows for inserting the new data at a specific location, like the beginning. After choosing an insertion method, the updated data frame is written back to the Excel file, effectively saving the new data. Post-submission, it's always nice to give users a clean form for further entries. The clear_form method does exactly that. If the data isn't valid, the user is prompted with a warning message. Additionally, any exceptions during the process result in an error message, informing the user that something went wrong.